assignment activity got over, or still it's going on?
It's happening in different slots now.
Oh,
Like
okay.
depends on which slot we choose.
Okay, okay, fine. Okay, anyways, I'll continue. Okay, in the last class, Shriba ma'am completed intermediate representations. You know how different types of intermediate representations are used, and also you know the importance of intermediate representation. And at various levels, you can also optimize in the intermediate representation, so that we have seen. Let us proceed with the next topic. Actually, the symbol table is used in all the phases. But anyway, this is the right time to tell, because almost we are done with our front end, and how the symbol table is getting updated, we will see. Okay, so this slide you would have already seen, ma'am also showed. Uh, so the front end is nothing but we have the three types of analysis: lexical analysis, then syntax analysis, which is also known as parsing, and then we saw semantic analysis. So these are the part of the front end. Okay, and as a part of semantic analysis, we have seen the syntax directed translation, which is used in many tools. Okay, and the result of this front end is nothing but the intermediate representation. So we will be using any of these intermediate representations, and we can optimize and so on. So before we go to the back end, that is, we have the remaining phases like selection of the machine instructions, and then optimization at that level also. So those things, and even the scheduling, these things comes towards the back end. So before that, what we do is we will have to maintain all our data in some data structure. Okay, so you may ask why we have to maintain separately when we already have the intermediate representation. So that may not be very good. Later, I will explain in the slides what are the advantages and disadvantages. So as of now, you can imagine there is one data structure that is maintained at every phase, and it gets updated. Starting from the lexical analysis phase, it gets updated. Like you will maintain some variable names, and for those variables you get some data type. Then we get the values, then we allocate somewhere some location is used. These are the things that we have to manage. Okay, and these variables are also accessed in the various part of your program, isn't it? So it need to be updated as it gets the different attributes. So what are these, then we'll see. So coming to the names of these variables and different data we are going to use, and it has to be updated in the symbol table. So how does it look like? Suppose I use a variable. If it is a normal variable, then some of the attributes associated with it will be, say, the data type, and the storage class, and then level also, because maybe I will use the same variable name at different levels within the function, outside the function, local variable, global variable, and so on. So that is also important. And then any variable, when I say it is associated with the address, means it is allocated somewhere in the memory and it has the address. So we call it as the base address. And if at all you have saved in the consecutive locations, like one after the other variables, so you know the base address means you can find the next variable where it can be. If you know the size of the variable, then you can easily find out what is the next location where the next variable is saved, and so on. Like in array it happens. So if you know the base address, you can find a particular element where it is saved in the array. So that all is required, and it has to be maintained. So array, also when you take up array, we are going to use the name for array also. And here we also should take care of the number of dimensions, and what is the upper bound and the lower bound for each dimension. That is the size you should know. Okay. And similarly there are many other structures, like we can also have the records or the structures where you may have more than one field. Like if you take a student data, you'll have a student name, student registration number, student marks, students, so many other attributes are there, right? So those things also have to be taken care, right? So all these data have to be stored somewhere and it has to be retrieved whenever it is required. So here also we will be using some name for records and structures, and the relevant information will be updated in the table. Similarly, we also have the functions and procedures. So once you take the functions and procedures, the number of parameters you are going to take and their corresponding data type, and what is the return value, what is the type of the return value, all these are important. So these names play a very important role in our source code. So if you start from the lexical analysis phase, you would have already classified some things as constants, some things as keywords, some things as identifiers, and these identifiers, we write the similar regular expression for all these kind of identifiers, whether it is a normal variable or array variable or record variable, structure variable or function variable, whatever. So all these we will be using the similar kind of regular expression. So we should be able to differentiate between this, and also we should track the attributes with respect to this. So that is what is maintained in the symbol table. Okay. So what is the necessity of this? We will try to understand. Already have seen what is abstract syntax tree. Compared to the past tree, abstract syntax tree will have less information, means it will not have everything in the tree structure itself, whereas in the parsing or in the syntax tree you have every stage of the derivation process or the reduction process that is shown. Whereas in the abstract syntax only the structure is shown, and we remove a lot of information. But also we add some things like the attributes, like the type can be associated, and the value can be associated. Like you would have seen some graphs like data dependency graph, you would have seen such kind of graphs where how the different attributes, how whether it is from top to bottom or bottom to top, how it moves, how it the dependency exists, those things you have seen. Now you may ask why that is not sufficient for the maintenance of data. That may be there, but the thing is the advantage is there that it can have a single representation of the entire code that is compiled. That is the advantage, but there is also a disadvantage. What is the disadvantage? We will see. The disadvantage is navigating through the abstract syntax tree. So it is very inefficient to go through. If I want a value, then I have to go through the entire, starting from root, I have to reach till leaf, and then I get the value, something like that. Similarly, if I am taking from bottom up, then I have to see from the leaf and then move towards the top. So this navigation is taking more time. Therefore it may not be very efficient to use the same abstract syntax tree in all the phases. Maybe it is very good to use it in the semantic analysis space, or it may be good to use in the intermediate representation to some extent. Even then we try to make it very efficient by removing some duplicate nodes, all that, isn't it? So this is the disadvantage. Even though we have lot of representations already maintained, but that is not sufficient, because to access it easily and with the speed, it is difficult. Therefore we use the better solution, which is nothing but the symbol table. So of course the space and the overhead to access this IR will be there. That is why we go with this solution, which is symbol table. So now let us see what is the symbol table. The symbol table is nothing but a central repository where you are going to have all the data related to any of your variables that you have used in your source code, and it gets updated in every phase, and you'll be using it. One thing is that you insert the values, you insert the attributes into your table, you maintain that, and on the other hand you also use it in the other part of your program. So it has to be updated now and then in every phase. So it is a central repository. And what are the advantages of using this? So it is very easy to locate the information that are derived from different parts of your source code. Suppose you have some more than two functions, then from different function you would have used some variables and it gets updated in each part of the function. So it is very easy for you to locate that value, to locate those attributes related to those variables. Okay, so that is the first advantage. Then the next thing is it is very easy to maintain and it is very easy to even retrieve the data from these kind of tables, because the structure is very simple, and therefore it simplifies the design and implementation of any code, whatever may be the number of variables you use in your code, that's okay, but it maintains properly systematically, and therefore it will be easy for design and implementing. And also it is not very expensive to search through the symbol table compared to the intermediate representation, where intermediate representation you have your own way to represent it and you are trying to optimize, but symbol table is used throughout, therefore this should not be very expensive, therefore we use a very simple structure for it. Okay, and using a symbol table eliminates the need to represent the declarations directly in the IR. Already we have told many times IR is independent of the source language and the target machine. Therefore, that let it be independent only. Now, when we are maintaining the symbol table, in the front end, it is always towards your source code. So those variable names, the data type, all that will be maintained. And in the back end, the same thing will be utilized, and then you convert into some kind of machine instructions and then use it. Maybe based on the architecture, whether you are using the register model or the memory model, based on that you'll be using. So rather than using the intermediate representation for the data maintenance, it's better to have the symbol table. So let us see how to implement this symbol table. To implement the symbol table, we use a very simple concept which is known as the hash tables, and we will be using the hash function, say h, and this will take up the name of the variables and it will map onto the small integers. Okay, so you can imagine you have already learned this concept, say hash table. Whenever you take the hash table, you need the size of the hash table, and it can be some variable size, because it depends upon the requirement. Suppose I want to have more number of variables to be maintained, then I will be increasing the size of the hash table, and if you have very less information to be maintained, then you can have less number of locations in the hash table. So based on your requirement, maybe you can plan to take the size of the hash table. And also the important thing is that whenever we find the hash value, as I mentioned, the input for the hash is what the name of the variable. So for this name I map onto some integer. This integer is nothing but the location used in the hash table. So later in the next slide I'll show how it is organized. So this, when we are doing this, there should not be collision, in the sense if you go on adding the variable names into the same location, what happens, then you will have to maintain some linked list, and then there also the searching becomes, as it goes with more number of names in the same location, the searching also will be, it will take more time. So we have to write or we have to implement the hash table in such a way that it is sufficient enough and it will not have any collisions. So if at all the collisions are there, then it will be difficult for getting inserting, as well as for getting the values also, it will not be very efficient. It's not that it is not possible, definitely it is possible, but if you are clustering everything into one particular location, it is not a good way of using it. Okay, so anyways, hash table is used, and you can select in this particular example, we have 10 locations, means the size is 10, 0 to 9 is what is used. And here you can imagine that it's nothing but a very simple function, that is the mod function has been used. You take some variable name and you apply take the integer value and um, apply the mod function with respect to the size, and you get the location, and you map this particular variable onto the location. And for each variable, maybe you can have various fields also, like you can have the type, value, level, these things also can be maintained. So later that will be shown. So this is the organization of the symbol table. And what is the advantage of using this kind of hash table is it will take a constant amount of time for the lookup. Lookup means you have already saved some variable name and its corresponding attributes into the table, and then this node, if I have to access, it takes a constant amount of time. Because as I already mentioned, if you use intermediate representation, it will be expensive, because most of it is like tree structure and you have to navigate through, and you have to get access to those variables. So instead of that, this will be easy, and it will take less time. So this hash function also, whatever we are going to select, should not be very expensive to compute. Because why we are doing all this, we want to increase the efficiency, means we want to increase the speed. So it should not take much time to even compute this hash function. At the same time, it should be a strong function, so that it does not have a collision. Okay, so in that way we have to select the hash function which is less expensive to compute, and also it avoids collision. Okay, so that kind of function we call it as perfect hash function, where it will not have the collision. Okay, so how long, or how what is the size of the table, it depends upon your requirement. So based on that, you can select the size of the hash table. So building a symbol table, there are two basic operations in the symbol table. One is that the lookup means already the symbol has been entered into the symbol table, and you are only searching for it because you want to access something from that, and that operation is known as lookup. If at all that particular name already exists, then it will give the value whatever is required from the user, so that will be returned. Otherwise, if it is not found, it means that earlier that entry was not made for that particular variable, so it has to be inserted. So the appropriate error message will be given. Okay, so that is the first operation. And the second thing is that the insertion operation, where we are going to insert the new symbol onto the symbol table along with its attributes, which we can call it as record. And how it is maintained, later I will explain. So insert the name and the corresponding record. This is going to be stored into the hash table with some location there. After performing that hash function, whatever location it finds, it will create a node and it will be saved there. So these are the two basic operations that are required in the symbol table. So this lookup of an undeclared variable, as I mentioned, it will fail if it is not existing. Means you have not made an entry into that table, and you are still using in some part of your code. And if you want to retrieve that, it is not existing, so it will fail. So at some point, like if you there are some rules, like in some programming languages we say no, it has to be declared before use. So that it will check. If it is already declared, then it would have already made entry for that particular variable also, and that variable exists, and maybe the corresponding attributes like the value associated with the variable also will exist after the semantic analysis. Okay, so if that exists, then there is no issue, the evaluation continues. Otherwise it will have to give the error message. In processing the declaration syntax, the compiler builds up a set of attributes. I told you, no. So at each stage, it builds like at some stage it will know what is the data type. At some stage it will know what is the value. And whenever we use the assignment statement for that particular variable, a new value is assigned from the RHS. That also it has to be maintained. Means the same names we are using in different parts of the program, so that it has to take care, that scope it has to take it. And correspondingly the attributes are also updated for those. Means at one part of the program, maybe I would have declared it as int some integer a, and in other part maybe I would have declared float a. So how does it handle this? All this have to be maintained properly with respect to the symbol table, and this lexical scope have to be used in that case. Okay, so while building the symbol table, it takes care of all these things. So let us take one example where you have the nested scopes. especially when you have the block structured programming languages. There you are allowed to use the same names at different parts at different levels. Then how does it maintain? So let us see that. If you see this particular example, we have used okay, starting from the first line, this is like a static int w, so this has been declared already. And let us take it as level 0. This is the level 0. For w it is taking as level 0. And next one more variable is declared, which is x, that is of type int, and that is also at level 0. Let us take like that. uh, and later we have some part of the code where we have the function. The name of the function is say example. You can see that here we are having two parameters that are coming in. So whenever you use the variable name as say example, and if you have this particular syntax, we can make out that it is not just the normal variable, it is the name of the function. Okay, so that anyway in the various phases it would have identified by using the syntax analysis, it would have already found. Therefore now these are parameters, so these are also at level 0 only, because it is the incoming parameter. And then once you enter into your function, the scope will change. Means now whatever variables I'm going to use from here onwards, I can see how at different levels they are used. I told it is a block structure, means you have different blocks within your code, and you also have the nested scopes. So you have something declared, and inside again in some part of your code you would have declared once again, and the values may vary, all that, right? So here int c, we can take it as level 1 because it is inside the function as it starts. No, this is the begin of the scope, I would say. This is the begin of the scope. Okay, and once this scope starts, it is at level 1. Now coming to the next part is, so as you see the brackets, especially the C code or in many languages, you will have some begin and end of every block. Like if you have the if statement, or if you have any part of your code, you will have the begin and end of that particular block. So here also we have something called begin. So as we start, the scope also will begin for these variables which is declared here. Okay, so B and Z are in another scope. Say I can call it as a level 2a. That is why, because inside this function I started with level 1, and then this part it closes the scope here. Actually this scope closes here, and again the next scope starts here, isn't it? So it starts here, and based on that only we are going to check. And we are going to take the innermost scope always, because that is declared recently, like how we handle the loop part, similar to that. So this is the begin. I don't know, it's not working properly. So this is the begin and this is the end. Similarly, this is the begin, and we will see inside whether something is there or not. Whenever it is nested, you keep increasing the level so that you know what value it is going to use in the evaluation of the expression. So coming to this part, so level 2a ends over here, and then we have what, the next level, that is beginning, but it is again within the function, so we can call it as level 2b. So in that we have variable declaration, say int a and x. So you note that this a was already declared here also as a parameter, incoming parameter, and this x also we had one global variable x. Here also we have in the level 2b, so that is once again declared. Anyway, here it is the same data type, but we have to see the values also. It's not just the data type, we have to see the values also. So coming to this, within level 2b, what is happening? Again, I have another block, which is this block. So we can call it as level 3, and the begin and end of the level 3 is this. This is what is the begin and end. Okay, within this level 3, what is happening? We have some declarations like C and X. Note that C was also declared in the level 1 here, level 1, and then X is already, it was a global variable, and also X we have declared in level 2b, and X has been declared in level 3 also. Okay, now when we are evaluating some expression, what happens, we will see. So this is what we want to evaluate. So coming to the maintenance of the levels and the names, here we have level 0, we have wx and the name of the variables as well as the name of the function we have maintained, because the way we represent is similar, only it differs in the syntax, that's all. The name looks similar, the rules used for the name looks similar. So wx and example are at level 0, and at level 1 we have a b c, that's what I told you. A b c, that is the entry of your function. And then we have 2a, because within the function we have some part of the code which has a separate declaration, so that is b and z, and then that terminates, and then we have another part within that function, another block, say 2b, we have ax, and within that we have nested one more block which is level 3, and that's what we have cx. So this is what we have. And now within this innermost block, what we are doing is we are trying to evaluate something. Okay, now how does it work then? So starting from okay, we have b is equal to a plus b plus c plus w. Anyway, the RHS has to be computed first, isn't it? The RHS will be taken first, and the value, whatever it computes, that will be assigned to the left hand side variable. So coming with a, so a is what you have to, whenever you want some value or the attribute related to that particular variable, you are going to see in the current level first, that is in the current scope first. If it is existing, you'll be using that. If it is not existing, then you will see the surrounding scope. Like now I want to get the value related to a, because I want to perform some arithmetic operation now. So a is of what type? It is you have to find out, because you have to see the scope now. A is not declared in the current block, that is in the level 3 we are not finding, but in level 2b we can find, isn't it? So that is the next surrounding block. Okay, and also note that it has been taken as an incoming argument or the parameter to the function. But what we are using is whatever is recently computed or recently declared only we are going to use. So for A, because it is not existing in the current block, you see the surrounding block, and from there you take, that is why we are going to use the value related to A to B. Okay, plus, see this dot dot means it will have some computation there, let us not worry about it, but anyway there may be some changes can happen within that block. So that's what we are trying to use the recent values which is computed for A, that is A to B. Coming to the next operand is B. So B is what you are going to see whether it exists in the current block or not. No. So in the level 3 B does not exist, then you go with the level 2B. Level 2B also you don't have, isn't it? Then you are going to go with which scope, you have to see now carefully. So after this, this is the begin and end. I don't know, this is not working properly, I wanted to show. This is one block and this is another block. Okay, so I am computing within this. So what is happening now, if I want to get the value of B, it will see in level 3 it is not existing, and it will see the surrounding which is level 2B. But should we take level 2A for B, students? Yes or no?
No, ma'am.
No. Why? Because that is an independent block, isn't it? It is an independent block. So what value we are going to use then? We are going to use the value that is from the level 1 only. Okay, that is from level 1 means this value only we are going to use. So that is why it is B1. Okay, that is why it is B1. So coming to the next operand is what? C. C is already declared in the same level, that is in the same block. So we can directly use that. Okay, so C is from level 3 itself. Suppose C was not there in level 3, then I would have seen in the level 2B. If that is also not there means I would have gone to the level 1 and I would have used level 1 for C. So that is done. So coming to W is, if you see in the current block, it is not there, in the surrounding block also it is not there, and level 2A we can't use because it is independent block. And then coming to the local variable declaration within the function also I don't have, And also I don't have as an incoming argument, that is w is not there as part of that also. Then what do? Then we have to go to the global declaration where it has been declared. Okay, so that is why we are going to use this, that is the level 0, because we could not find anything that is not there in the scope of this function at all. So the external function means, or the external thing means, it is the global variable only. That's why we are going to use w naught, that is the level 0. Here the subscript is nothing but the level number. Okay, so w naught. So this has been evaluated, means you take the values from each level, that is for a, b, c and w, which I explained. So all this you're going to take and you're going to compute with respect to the order. Anyway, you know that how it will be done using the semantic analysis. Already the syntax analysis phase would have decided in what order it has to be computed. In the semantic analysis, it will check the type, whether it is proper or not, whether it is legal to do it. It will check, and based on that, now the operation can happen, and the values are also available. Only if the values are available, it can perform the computation. How it will check? Then it will go to the symbol table, try to retrieve. So once I say a to b means, it has to go to that particular table and get the access to that attribute value, and then it takes that and it computes now. So it happens like this. So once the RHS, all my operand values are ready, then it will perform that evaluation, and whatever value it gets, that should be assigned to another variable, which is the LHS symbol. So this LHS symbol, again you need the scope for this LHS symbol. So as you know, it is B is not there in the level 3, B is not there in the level 2B, and level 2A it is independent. Therefore, I will have to take the B which is with respect to level 1 only. Okay, so that's why it is known as B1 is equal to whatever computed value, it will be saved into B1. So it works like this. And this concept, we call it as the levels. What I said, we call it as lexical scoping. Okay, lexical scoping at different levels. So let us see more about it. Whatever I explained, the same thing is there in this particular slide. So the name resolution maps each reference to the lexical level, means even though I use the same names at different parts of my code, it's okay, because we can easily manage using the levels, and the recent ones only will be used, and if it is nested, it will see the surrounding, and if it is independent, based on that, it will see for the computation, during the computation it will be taken care. Okay, only thing is that you have to maintain this lexical level and the symbol tables corresponding to that. That if you are able to do it properly, then you will be able to get all the attribute values whatever you need for the computation. So this is scoped symbol tables is a requirement, because then only you will know at what level what is accessed and what is the value at that instant of time. Therefore, it also helps in the code optimization, because you can know where is the scope ending, where is it beginning, if the scope ends, whether I'm using it in the future or not, whether it has become a dead variable. These things also you can analyze. So once you analyze, you can also optimize. Sometimes what happens, most of the variables whatever we use, maybe temporarily we will save and we will not be using it later. So those things can be eliminated. So it also helps in the code optimization. If it is not of any use, we can remove it. Okay, so maintenance of symbol tables, especially the scoped symbol tables, will have a direct application in the code optimization. Okay, so now coming to how does it maintain all these then? Definitely one single symbol table will not be sufficient. If you have only one global table, you will not be able to differentiate between whether it is at level 0 or level 1 or level 2 and so on. And you cannot imagine the languages, the source languages, which are always like only it will have one function or two functions, nothing like that. You can have the modern languages where lot of opportunities are there to have all kind of syntax, and I told you the block structured, you have the nested uh, things, and you have the return values also. uh, there are many options. If you take some modern languages, it has got a lot of options. So those also it has to be able to manage. Therefore we need the shelf of tables. It is not a single table now. We need a shelf of symbol tables, and we need to implement that, including the lexical scope, And every time the scope changes, you will have to create a new symbol table, and also you should provide a link to the previous table so that it has access. Whenever you have the nested things, you should have a backlink going to the surrounding, that is, you should be able to access the surrounding scope symbol table, and that's how you can get the values. So let us see how it looks like. For the same, for the same example what I took in my previous slide, let us see how the symbol tables are maintained. Okay, as I mentioned, we have to maintain a different level. So starting from level 0, at the level 0, what are the variables? We know it is w, x, and example. So those entries are made into the symbol table. And also don't imagine only one field for these variables. Definitely it will have more fields. It should look like a node. Okay, means for x, what is its data type, what is its value. Okay, those things also have to be maintained. And if it is like indirect addressing, maybe that memory location also need to be tracked. So these things have to be maintained. So definitely the linked list would be the best option for implementing this. Anyway, that I'm going to cover later. So at level 0, all these variables, that is x, example, and w, are maintained. Okay, and this location, how it decided? Based on our function, that's all. So x has been allocated in some location, means we would have executed some function for this particular variable name, and it has been located here, means it has been inserted here. Similarly for other variables also. So I created level 0. Then I move forward to the next part of my code, which is nothing but as you enter into your function, now the scope of the variables will change. You have some incoming arguments, you have some local variables into the function, and also we have different parts of your blocks, and so that also need to be maintained. So at level 1, what happens? I have to create another table because now the level changes, right? We can't have the same level 0 table, symbol table, for the function part. So what we do is we create another table, and we provide a link to level 0. Why we are providing? Because if I want to use the surrounding value, like at the end, no, w naught only I am using for the computation. So this w naught, how will I get? Then I have to traverse through this, and I have to reach level 0, and I get the value over there. So I use that for the computation. So therefore that link should be there, the pointer should be there. So level 1, we have b, a, and c, and this has been located based on our function only. Once again, so there is no order maintained. Actually, it will take the variable, and for that particular variable name, it will implement using that function, hash function, and finds the location and allocate there. That's it. So then we enter into the, okay, for this particular execution of this statement only, it has been created now. And you notice that we have never used level 2a variables in our computation, that is b is equal to a plus b plus c plus w. So accordingly it has been created. So how to show how it has been accessing, that's all. So anyway, the tables would have been created for level 2a also. Table will be created, but the way I use is what? I start from the current level, that is the level 3. I have access to x and c. Whatever I want to use, maybe c I will use for level 3, and then I want to get the uh, level 2 b values for a, then I go access the value of a, and then I want the value of b, which is not there in level 3, not there in level 2, then it goes to level 1 and uses that value, and so on. So it goes like this. So this particular structure is only to show how the execution of this particular expression takes place, like how the links are used to access the surrounding symbol tables. So it works like this. Okay, so in this way we have to take care of the scope of each variable. That's why it's very important to close the scope whenever you start. You cannot simply write everything into one particular block. It is not like that. Many times we have requirement to have the nested scope and the nested code structure. Therefore accordingly you'll be having maintaining that. So the begin and end of the scope or the lexical level is very important, because that decides the maintenance of the symbol table also, and that decides on the evaluation value, otherwise you may not get the desired result. Whatever you wanted, maybe you'll not get that. Therefore you will have to maintain this shelf of tables, and that need to be implemented like this. Okay, so if at all you have another expression, say within level 2a, if you have some expression accordingly, that also will be evaluated, and maybe you can show the snapshot, like something like this, how it will access various variables. Suppose I have not defined z at all into my symbol table, then it will give an error, because I want to use this z somewhere in my computation, but z is not existing in the level 2a table. Therefore it will first search in level 2a. If it is not existing, it will search in level 1. That also it is not existing, means it will go to level 0. There also, if it is not existing, then it will show an error message. Okay, so that's how it will find the attributes of each variable. So the maintenance of this is very important. Okay, so this is known as the shelf of tables, and it has to be implemented like this. Whatever I told, the same thing is given here in this. So the lower number, so always we start with the lower number lexical levels. As we go into the nested part of the code, we rename it by incrementing the values, like how we did level 0, then level 1, and then level 2a, because there were two blocks, 2a and 2b we classified, and within 2b again there was one more block, so we called it as level 3. Similarly, in the level 2a also, if you had one more block, maybe you would have taken some other level, like inside, if you have, say, maybe there also you would have taken level 3, but the surrounding will be level 2a. Something like this we would have created. Okay, so the numbers will decide the lexical level, and the begin and end will decide how to access the values in that scope. Okay, so the declaration of the variable is very important, and the values associated with those variables are also important, because most of the time we use the same variable names, and the scope is important. Okay, so that's how we do this. Whether I have time? Okay, some more minutes I can take, another 2 3 minutes I'll take. uh, I'll just give the introduction to this. Maybe I will take up this in the next class. So the symbol table, how does it look like, the storage? It will look like this. So maybe you can use something called static coordinate. The name itself says it is static, means it is like fixed. This structure is fixed, kind of thing, and at the compilation time we use this static coordinate. Suppose you want to change often, then you'll be going with the runtime coordinate, that is the dynamic coordinate we are going to use, that we are going to discuss in the next chapter maybe. So at this stage we will only deal with the static coordinate, which is with respect to the compile time. Okay, so means I know all the variables what I am going to use, and all the values are also available at the maybe at the compile time, and that's how we have. So this is nothing but it has two fields, the level and the offset. Level will decide at what level you are having, and the offset is means from the base address, what is the difference to access that. Means like if I start the array variable with 8000 location, and I want to access some fourth element, I can easily find the offset of this particular variable where it exists. So something like that. So if I know the level and if I know the offset, then I can easily get that particular value where it is present in the memory. So the variable which is stored in the memory, I can easily get it by knowing the level and the offset. Okay, so we use the static coordinate to represent for each variable, and at each level how it is stored you can easily access. Okay, so this anyway I'm going to touch it maybe in the next class, because it is having too many things. Shelf of tables already I have explained, but maybe we to implement that we'll be using some functions, like we are going to initialize initially with the new symbol table for that particular scope, and then finally when you go towards the end, when you evaluate the expression, you can see the final table. Means I told you, no, in that particular expression itself, b1 is equal to something you have in the RHS. So final value of b1 is what, after the execution of that expression in the RHS, whatever value you get, that will is supposed to be in b1 finally. So initially what you have in the table is one thing, and finally after the computation of something, what is there for the corresponding variables, that also matters. Because as you proceed your execution, the values get assigned and you're going to use it, and that will be the final value. That's why we always take the recent value, because that has been computed recently, and that's what is saved also in the symbol table. Means it will overwrite, if we are using the same scope also. What happens if I'm using b at different places at the same block, whatever is recent one, that only value will be available. So it takes like that. So, and we also want the in the same way, therefore it happens. Okay, these things maybe I will touch it in the next class, because time will not be sufficient to complete everything. Okay, students, I think I can stop here. This portion is little like theory, but anyway it is important. Compared to other topics, definitely you feel little bored. Okay, any doubts with respect to this portion, you can ask. Students, are you all there, or what happened? Students?
No doubts, ma'am.
Yes,
No
no doubt.
doubts. Okay, 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 fine. Yeah. Okay. It's a simple topic. Yeah, as we proceed further with lot of functions and abstraction, then maybe you will know. You'll get some doubts.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Yes, students.